Hello friends, so in today's question, in the arrangement shown in the figure, mass of the rod capital M exceeds the mass small m of the ball. The ball has an opening permitting it to slide along the thread with some friction. The mass of the pulley and the friction in its axle are negligible. At the initial moment, the ball was located opposite the lower end of the rod. When set free, both bodies begin moving with constant accelerations. Find the friction force between the ball and the thread. If t seconds after the beginning of the motion, the ball got opposite to the upper end of the rod length is equal to L. So this is given as the initial condition. The ball whose mass is small m is at the lower end of this rod whose length is L and mass is capital L, and after t seconds, the ball comes at the upper end of this rod. So total distance traveled by the ball will be equal to L. You can see that it is given that mass of the ball is equal to small m and mass of the rod is capital M. So this is the original you can see initial condition, and the final condition we can draw it like this. So this is the pulley and this is the rod, and in the final condition this mass is at the upper end of this rod. So the various is capital M and this is small m. So there will be a force acting in the downward direction, that is mg, and for this small mass there will be also mg, and it is going to have at a continuous thread tension T, and let us suppose they have the acceleration of a1 and a2. So acceleration of small m is a1 downward direction, and of mass capital M is a2 and it is also in downward direction. So these are some of the forces which is acting on it. We can see that acceleration of mass small m is a1 in the downward direction, and acceleration of mass capital M is a2 and it is also in downward direction. And it is given that the force of friction, there is some force of friction, so we can say that let the force of friction between thread and the ball of mass small m is equal to Fr. So now we can write the respective equations. Okay, so you can see that for mass capital M, we can write the equation mg minus t is equal to ma1. Let this be equation number 1. And we have for mass small m, the equation is mg minus t is equal to, sorry, it is a2 and this is ma1, equation number 2. So if we subtract equation 2 and 1, subtracting, equation 2 and 1, we get rather what we can do, we can find out a2 and a1 and then we can sort it out. So we can say that a2 minus a1 will be equal to mg minus t divided by capital M minus, and the second term is mg minus t divided by small m. Okay, so let us write this as a2 is equal to mg minus t divided by capital M and call this equation number 1. And from here we can say that a1 is equal to mg minus t divided by m, and this is equation number 2. Now it's correct. Now what happens after time t? The ball reaches the upper end of the, you can say, rod. Under this condition, the force of the tension and the force of the friction will be balancing each other. They will be equal. Okay, so we can say that after time t seconds, the ball travels a distance of L, which is nothing but length of the rod, thus tension will be equal to force of friction, and let us call this equation number 3 and this as equation number 4. So substituting the tension, value of tension as force of friction from equation 4 into equation 3. Okay, using equation 4 in equation 3, we get a2 minus a1 is equal to mg minus fr divided by capital M minus mg minus fr divided by small m. Let us call this equation number 5. And now we already said that the distance traveled by the ball in time t is L. Okay, so we are going to use the equation of the kinematics. Okay, using equation of kinematics states that S is equal to ut plus half at square, as entire system was at rest initially, okay, as entire system was at rest, so we can say that u will be equal to 0, and net acceleration that is a will be equal to a2 minus a1, and finally the distance traveled s will be nothing but length of the rod. So substituting the value, we can say that L is equal to half a2 minus a1 into t square, and from here we can find out that a2 minus a1 will be equal to twice L divided by t square, and we already know value of a2 minus a1. Okay, so we can say that using equation 5 we get, substitute the values, and we can take the LCM also. So the LCM will be capital M multiplied by small m, and we get this as small m mg minus fr minus capital M small m and fr is equal to 2L upon t square. So if you open the bracket, we get minus mfr minus mg plus mfr divided by capital M small m is equal to 2L upon t square. Sorry. These terms cancels out, and we can take fr as common. So we can write fr will be equal to capital M minus small m is equal to twice L m upon t square. So from here you can see the force of friction will be equal to twice L m upon capital M minus small m into t square. So this is the value of the force of the friction. Okay, this is nothing but friction force between ball and thread after t seconds. Thank you.